So in this video, we'll look at the topic of integration for the trigonometric functions, where both functions now are tangent x and secant x, and both functions have the certain exponents on top of that. And in the last video, we have looked at the case where the n above the secant x must be even, and I claim that it can be solved by a u substitution, which is u equals tangent x. And in the current case, we'll look at another scenario where both mn are odd, both. So I claim that the way to use is u equals secant x, and let's see whether it works out or not. So please look at the current problem. You see both power are 3, which are odd. So it satisfies our conditions here. And as I claim above in the purple color, we have to use u equals secant x. And it means that the u is the same as the derivative for the secant x, which is secant x times tangent x. And let's see whether it works or not. You see the key is that the u take out one copy of secant x and one copy of tangent x, right? So let's write the next step this way. So both secant x and tangent x has one copy taken out. Tangent x secant x times dx, because one copy of tangent x and one copy of secant x are absorbed by du, right? So now, as a u substitution problem, you have to convert all the variables into u. Secant square x is clear because u is itself secant x. So secant square x is u square. How about tangent square x? And we have to make use of the famous identity, which is 1 plus tangent square x equals secant square x. And now you see tangent square x is going to be the same as secant square x minus 1, which is u square minus 1, right? So tangent square x is the same as u square minus 1. And at this stage, I hope you can see why I want both of the mn to be odd to apply this method, because of the fact that the du actually takes out one copy of tangent and secant each, and the remaining copies here, both of them must be even. The secant is clear because u itself is actually secant, so we can easily convert the secant x to any power back to u. However, this one we need it to be even, so we can make use of the formula in the purple star box for the tangent part, because even if tangent has a higher even power, let's say tangent to the power 4x, we still can apply this trick, right? We just have to take the power for the u square minus 1 to a higher power. But anyway, for the current problem, now it's a u substitution problem. You have to integrate u square minus 1 times u square times u, and of course the remaining is just algebraic manipulations. So you can distribute u square in, and it becomes the integral of u to the power 4 minus u square du. And simply by power rule, we can write down the answer this way. And of course, u itself is actually secant x. So I can write the answer in this way. And that's the end to this problem.